Welcome to Injury Scale Models. I'm your host, and I do models. Today we are going to answer a question from a viewer that I thought was pretty interesting and was deserving of a video. Let's take a look at the thing. It says, how much should the voltage difference be between two inputs to be considered low or high? For example, if one input is taking 5 volts and the other input is taking 3 volts, does this make 5 volt high, or does low have to be 0? Okay, now if I think I understand this question correctly, if you have an input, if you're trying to drive an input that is less than 5 volts, and then you have an input that is directly 5 volts, does that affect the chip? And the answer is no, because the chip itself, let me go to the overhead camera and try to turn that on. And let me move it down here. If you look at the chip here, here's the chip down here. This is a LS7400. Let me get my quick and dirty data sheet here. Should have had that already done here. Okay, so I can put this. So there's the data sheet. This is a quadruple 2-input positive NAND gate. So I'm going to hook this up, but if you look, it has a ground pin. It has a positive pin VCC here and a ground pin here, so it gets its own supply of voltage, and the TTL chips are recommended for 5 volts. So let's go over here, and I have to turn this off manually. So I'm going to plug this chip in right about here, and I'm going to plug in 5 volts to it, and we're going to test this theory, and I'm going to talk about it here. So we're going to plug in 5 volts to pin 14, and then pin 7 is going to get 5 volts. So we have that. Now our output is pin 3, so I'm going to take my pin 3 output and I'm going to slap it over here. And what I'm going to do is I'm going to take a blue LED and put it on that output here. So remember, the cathode is the negative, and I bend my leads so they fit, and this is the cathode. So it's going to come through here with a 5 volt high, and it will go there. And then I will put a 470 ohm resistor in sequence to keep the current down. And normally I would drive these with a transistor, but I'm just going to do this dirty. So now let me show you 2 different ways to get 2 different voltages into a thing. So we're going to use red for the high voltage and green for the low voltage. So for the low voltage, I'm going to connect that to that, and then I'm going to connect the red one like that. I'm going to connect the other side directly to the pin to the 5 volt rail, and you'll see how that has an effect. So there's not going to be a light on the red one, but we're going to put a light on the green one here, because I want to use the light of the LED to drop some voltage, so the inputs will be different. So we'll have roughly 5 volts here, and we'll have roughly 2.7 volts, but we will see that in the video here. Let me just tame that down a little bit. There we go. Okay, so that's all hooked up. Let's get some jumper wires in there. just going to use some crude jumper wires that I'm just going to bend up here. So this is going to be pin 1 right here. Pin 1 is going to go to the green switch, and then pin 2 of the chip is going to go to the red switch. So pin 2 of the chip. Now currently the chip is being pulled low. So when I apply power to this with my Singlet SPD 3303XE, you can visit the description in my GoFundMe or Patreon to help me pay for this test equipment. It's on loan to me at the moment. I would like to keep it to do more great videos like this. So let's plug in here. I'm going to pump in 9 volts. My little power supply up there is going to drop it to 5 volts. And we're going to plug it in, and this LED is going to light. It's because it's a NAND gate, so they both have to be pushed to make it go off. So if I press this, nothing happens. I press this, nothing happens. I press them both, the light goes out. But that's not that. We know how a NAND gate works. We all saw the video. Hopefully that video has been released. If not, I'm going to feel like, ooh, whoops. So let's take a look at some voltages here. So I'm going to take volts DC. It's on the screen. I'm going to plug in this to my ground rail, and I'm going to plug in to where, well, we'll plug right into pin 1 here. And when I press the button, I'm going to get about 2.9 volts. That's because the LED is dropping. That's the LED. The LED is dropping about 2.9. How is the LED dropping 2.9 volts? That doesn't make any sense. Anyways, we'll check the dual voltage drop of the LED in a minute. So as you can see, I have a input into this of roughly 3 volts. Now if I check the input of this pin and I press this, I have an input of roughly 5 volts. So I have the 2 different input voltages that Void was talking about in his question, and I am still getting a high output. Now there's going to be a voltage drop on this this LED, but the reason I use the NAND gate is because I want you to see it drop to 0 with 2 different voltages on the input. So I'm going to plug into here, and there's 4.7 volts going out because we have a high signal, and if I press both of them, it drops down to nothing. So it actually pulls it to ground with 2 different input voltages. So that is basically how it works, and it works that the TTL chip has its own internal power, and it has a range of signal, a range that it can see a signal. And we're going to bring out the notepad here. Hopefully what I have is still on here. Alright, we're going to bring out this notepad here. Okay. Well, we could probably do it on here. Yeah, we'll use the notepad. Okay, so if you have if you have 0 volts here, this is 0 volts, and we'll say that this right here is 5 volts. Now this isn't going to be perfectly to scale, but here's the thing. If you look at the data sheet on a TTL chip, their low voltage that registers, it registers a low right about here at 0.7 volts. Anything under that is a low, so this is the low. So this is the minimum low signal. Now the maximum low signal that this chip can see is right about here at 2.2. I don't know if it's right about there. But there's this range in here between 0.7 and 2.2, this range of indeterminacy. So you can have multiple different voltages trying to go to this one of these chips, but they all need to be within this range of 2.2 to 5 volts. So, and don't run your chips over 5 volts because they're TTL chips. They don't like that. CMOS chips, you want to run more voltage, get a CMOS chip. CMOS chips are actually better. I happen to like TTL chips, so, and they're cheap. So, but yeah, there's an indeterminate zone where it doesn't know if it's low or high. That's why I have issues if I run a blue LED on a switch, because it drops so much voltage that it won't register as a high input. It still thinks it's a low input. But that's going to do it for this video. I hope it answers the question. It was a good question. I liked it. It was worth making a video on. But I just wanted to share that with you guys and just clear up the fact that you can have different voltages coming into a gate. Make sure all your grounds are tied together and make sure your chip has power. So that's going to do it for this, guys. Links, social media, Patreon,